graphs, various visualization programs we are creating, and various audio, video, text graphics applications we are creating. Next, next application of generative AI, you can see, and write a Python program is to train a generative model, that is generative adversarial network GAN, to generate realistic synthetic healthcare data and visualize the results, enabling enhanced healthcare diagnostics through simulated patients' data. Now see, I am taking viral disease data set. This is a synthetic data set I have created with number of columns like ID, patient age, gender, temperature, symptoms, white blood cell count, viral load, then diagnosis. So up to 20 patients data I have created. Now I am writing a program. So I'm importing TensorFlow, and I'm importing Keras. So some layers like dense layer, reshape layer, plot and layer, leaky relu layer, batch normalization. Then in TensorFlow, Keras models like import sequential model. Then we are optimizers like Adam. Adam is an optimizer function. Then Matplotlib I'm using, NumPy, Pandas. Then this is the data set I have created. Provided data set with number of columns, and then normalize only numerical data for the GAN. I am applying a generative adversarial network. Then define a GAN components. So how to define a GAN, generative adversarial network? You need to define build generator. Then model you can derive from TensorFlow, from that one Keras. From that one you can derive sequential model. Then use layers like dense layer, leaky, relu function, batch normalization. My dense is 256, leak, rectified linear unit alpha 0.2, batch normalization, momentum 0.8, dense 512, leaky relu function alpha 0.2, batch normalization momentum 0.8, dense numerical shape, activation function is called sigmoid, and return model. Now, next, build a discriminator. So then under that discriminator, again, you need to use model, sequential model, dense function, input, and numerical function, and leaky rectified linear unit, and dense function, rectified linear unit. And you can use build GAN. Likewise, we are generating a discriminator and a generator, and various model parameters, fine tuning parameters we are using. Okay, so likewise, we are creating a simple neural network model. Then see the application build and compile the GAN. Then training the GAN, epochs I kept 100, batch size is 16. And then for each in range epochs, train discriminator. Then you can call it a train generator. Then print the progress, generate a new patient data, denormalize the generated data, then visualize the generated data, etc. So now I'm demonstrating this application. My dear friends, this is one application, very interested application. You can see, and likewise, you can generate your own application. If you have any problem, please give me. I will execute and I'll give you graphs. Okay. Generative AI 0. So this application is, now see, I'm opening this application, notepad space, generative AI 0. See now, write a Python program is to train a generative adversarial network GAN to generate realistic synthetic healthcare data and visualize the results, enabling enhanced healthcare diagnostics through simulated patient data. Now I'm importing TensorFlow. Then from that TensorFlow to Keras layers, I have explained already. So this is the program. Okay. Now I'm executing this program. Please see here, Python space generative generative AI 0. Now see, now I'm executing. See this one. So for that sample graph, I have generated a graph. Okay. So we can change this one also. We can generate various graphs also in place of that one. Okay. So that is see, this is the output. You can original data, and you can generate various kinds of applications. Okay. So likewise, we can generate. See, likewise, now this is the output. We got it. Then final output. Okay. And this is the final output generated data. Patient age, temperature, white blood cell count, viral load, etc. These are the graphs I have generated. See here. So these are the graphs I have generated for that age versus frequency, temperature versus frequency, then frequency versus white blood cell count, and viral load versus frequency likewise. Next program. Any doubt so far, my dear friends? One more application. Write a Python program is to demonstrate how generative AI can be utilized for data visualization using Python libraries, Matplotlib, and Seaborn to generate insightful and interactive visual representations of synthetic customer data. So here, create a data frame with synthetic customer data we have created, plotting that data, scatter plot of age versus income, and plot, I mean, we are plotting bar plot of spending score by age group, then a box plot of income by age group, heat map of the correlation matrix. Generative AI 1. See this one. If you see, generative AI 1. Now you can see notepad space generative AI. So this is the program. Write a Python program is to demonstrate how generative AI can be utilized for data visualization using Python libraries, Matplotlib, and Seaborn to generate insightful and interactive visual representation of synthetic customer data. Import NumPy as NP and Pandas, Matplotlib, Seaborn. So create the data frame, then plotting, bar plot, box plot, heat map, then finally I'm showing. So Python space generative AI1.py. See now? Now it is going to demonstrate. This only 28 members are there, Velingiri sir.
Yes, sir.
Why
Uh,
students left already? See now?
Sir,
My screen
students.
is visible, sir.
Yeah, visible, sir. Some students having exams, sir. Okay, that's why they
Oh,
left.
sorry, sorry.
No
It's
issue,
okay.
sir.
Yeah,
Continue.
yeah, yeah. Yeah. So see this graph, my dear friends. In x-axis, I have taken income distribution by age group. In y-axis, I have taken income and age versus income, spending score by age graph, and average spending score and correlation map. Then income, see bar plot. Now confusion matrix. Now here box plot, income versus age. So likewise, we can generate a confusion matrix. See here, confusion matrix. So likewise, we can generate various applications of generative AI. This is called a multiple visualization. See here, age versus income and spending score by age group. Okay. Why we are using scatter plot? It visualizes the relationship between age and income with the spending score influencing color and size. Then bar plot displays average spending score across and 1 second, sir. Hello, who's this one? Yeah, yeah. Tell me. I'm in session. Yeah, 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 yeah. Yeah, yeah, yeah. Can you call after 12 o'clock? Up to 12, I have a session. Sorry for disturbance. Yeah, yeah, sure, sure. Yeah, yeah, sure. Yeah, sure, sure. Please remind me. Yeah, yeah. srinu.asadi@gmail.com. Yeah, sure, sure. Okay, madam. Sure, sure. Okay, okay, bye. So now box plot we are it shows income distribution with each age group. Heat map represents the correlation matrix for age, income and spending score. Then here are the top 10 major tools of generative AI. My dear friends, see here. Generative AI tools are GPT, Generative Pre-trained Transformer, now 4 came. An advanced language model by OpenAI that generates humans like text based on given prompts. DAL-E. DAL-E is a neural network by OpenAI that creates images from a textual description. Then Deep Dream, a computer vision program by Google that enhances and generates images based on neural network interpretations. And then a style GAN. A style GAN is one of the generative AI tool, a generative adversarial network by NVIDIA that produces high quality realistic images. Then a BERT, bidirectional encoder, representations from transformers, a transformer based model by Google designed for natural language understanding task. Then Runway ML, it is also one of the generative AI tool. By using this tool, variety of generative models like art, design, and other creative projects we can create. Then Big GAN. Big GAN is nothing but is one of the generative AI tool. A GAN model by Google Research that generates high resolution images, Big GAN, which diverse and complex features, and VQVAE, vector quantized variational autoencoder. It is a AI model that combines VAEs and GANs to generate high quality images and audio. And MuseNet is also an AI model by OpenAI that generates 4 minutes musical composition with 10 different instruments. Talk to Transformer, that is one of the generative AI model, an interactive web-based tool that allows users to generate text using GPT-3 based on their input prompts. Then these are the AI tools like OpenAI. We have GPT-3 and Runway ML, Teapot IO, NVIDIA StyleGAN, Google's Magenta, and Unity's ML agents and JukeDeck. So these are the top 10 AI tools like GPT-4, DAL-E, and Midjourney, which are revolutionizing creative processes across industries by enabling rapid content generation, design, and problem solving, etc. So these are the other tools. Now ChatGPT is very famous. Likewise, each company having their own tools like GPT-4, GitHub, and Alpha Code, Bard, Cohere, Cloude, Synthesia, DAL-E 2, various tools are available. Now, in this generative AI model, we have top 10 major techniques. What are the major top techniques? Can you see now here? First one is a generative adversarial networks. I have explained already. Now, once again, I am explaining this one. So, GAN is a one of the generative AI technique. It involves two neural networks like generator neural network and a discriminator neural network. We are creating both that complete to produce realistic data. For that purpose, we are using GANs. Next, variational autoencoders. It is a generative model that learns to encode data into a latent space and then decode it back, allowing for the generation of new data samples. And the transformer models, advanced models that use attention mechanisms to handle dependencies in sequential data, ideal for language generation, self-supervised learning. It is a method where models learn to predict part of the input from other parts, useful for pre-training on large data sets. Text generation, by using ChatGPT, we can generate relevant text based on input prompts. Then image synthesis. If you want to create any real-time image or real-time video, audio, text graphics from scratch, use these models, GAN and VANs, in this image synthesis. Then music composition. If you want to create your own music, and by using these concepts, by training models and existing music data sets, you can create with the help of GANs and VANs, etc. Style transformer. It is also one of the technique for artistic style of one image to the content of another image using convolutional neural networks. It is a popular network technique in deep learning. Then data augmentation, generating new training examples by applying random transformations to existing data, enhancing model robustness. The last technique is synthetic data generation, creating artificial data that mimics real-time data to train machine learning models when real data is scarce or sensitive, etc. So these are the generative AI techniques. See here, GANs, VAE, reinforcement learning, CNN, RNN, autoencoders, transformers, etc. So, one of the most popular and the world's famous applications of generative AI is deepfake technology. My dear friends, deepfakes use generative adversarial networks to create a highly realistic synthetic media where the person is an existing image or video is replaced with someone else's likeness. So, similar images like twins, you cannot segregate, very tough to recognize and detect and predict this twin images. Likewise, we can create. So this technology has emerged under significant attention due to its applications in entertainment, such as creating digital avatars of actors, and its potential misuse in spreading misinformation. See like this. See which one is original. Can anyone recognize? Please tell me. See. Hello, sir. My screen is visible.
Yes, sir. Yes, sir.
So, my dear research scholars, see the original image girl would like to be a Rashmika Mandana. Okay. So, same body structure, same hairstyle, same glasses, everything is same. But deepfake image, see how to identify deepfake image. So in that case, we are using GANs and variational autoencoders. Okay, write a Python program is to generate synthetic handwritten digits using generative adversarial networks, that is called GANs. Okay, and visualize the results through various graphical representation. TensorFlow. So one program again, a digital handwriting Same digital handwriting, if you want to, I can generate by using this program. See, your signature is in the bank, you have done. Same style of signature I can create. So, likewise, people are doing. So that is one of the cyber crime related application. So by using this program, you can create. So TensorFlow we are declaring. From that one, we are using various layers. From that TensorFlow, we are using sequential model. For TensorFlow in Keras, we are using optimizer like Adam optimizer, flatten, reshape, then matplotlib for visualization, numpy for numeric Python, load and process the MNIST dataset, then define GAN components, generative adversarial network component, then build and compile the GAN, training the GAN. I'm taking epochs 100, batch size is 64, half batch I'm for each in range epochs, then generate and visualize new images. Okay, now this program I am executing. See here, generative AI 2. Now, see now, notepad space, generative, generative AI 2. See, this is the program. Write a Python program is to generate synthetic handwritten digits using generative adversarial networks and visualize the results through various graphical representation. Okay, TensorFlow I'm declaring and load and process the MNIST dataset, same thing. Now I'm executing Python space generative AI 2, generative AI 2 dot py. See, this is the graph we have generated. And if you see how it is going to load this one, handwritten digits using generative adversarial networks, GAN and visualize the results. So same type of image we can create and we can visualize and we can see that graphs. Next program is write a Python program is to train a generative adversarial network GAN to generate realistic images from the MNIST dataset using a generator to create new images and a discriminator to distinguish between real and generated images and then visualize the generated images. See here, I'm declaring TensorFlow load process the MNIST dataset, then go for define GAN components, build and compile the GAN, training the GAN, train a discriminator, train generator, print the progress, generate and visualize new images. See, GANs. If you use up, see now this program, see, GANs. You can notepad space gans.py. So the write a Python program is to train a generative adversarial network GAN to generate realistic images from the MNIST dataset using a generator to create new images and a discriminator to distinguish between real and generated images and then visualizing the generated images. Okay. And then now see, I'm executing this program, Python space gans.py. It takes, see, because of that TensorFlow, because of that TensorFlow not updated in my system. So see, like this, we are getting final output of our image like this visualization. And this is a where this is one more program by using a variational autoencoder, same data set. Like write a Python program trains generative AI model that is variational autoencoder VAE to generate realistic images from the MNIST dataset using an encoder to map input images to a latent space, a decoder to reconstruct images from the latent space, and a custom loss function to optimize both
Uh,
reconstruct images
Sir,
from the
Asadi
late.
here.
Sir, sir.
Sir, we have another 9 minutes remaining.
Yes,
Uh,
yes, yes.
sir,
Then we will ask queries.
yeah, yeah, yeah.
Parameters, encoder, sampling function, decoder, models, apply custom loss layer, compile the model, training the VAE, visualizing generated images. See now, I am executing a VAE model. So like this, we are getting output, variational autoencoders. See, 1 second. How to, here, you need to close this graph. Then here, CLS. So pip install, you can do like this. Pip install, pip install Keras. This library is up to date. You need to update. Then only see now it is updating. Yeah. Next TensorFlow. Pip install like this. You need to do. Pip install TensorFlow. Next again we need to do. See. Next pip install Torch. Pip install Torch. Okay. Next pip install Pandas. Like this, you can update your libraries. Now, Notepad space VAE variational autoencoder. This write a Python program trains a variational autoencoder to generate realistic images from the MNIST dataset using an encoder to map input images to a latent space and then a decoder to reconstruct images from the latent space and a custom loss function to optimize both reconstruction and latent space regularization, then visualizes the generated images. Okay. Now, Python space VAE. Now see. So this is the sample data, but usually we are getting the output is like this, auto variational encoders. So this is the output we are getting. So with this one, uh, any doubts, if you are having, please ask me. And my dear participants, 29 members are there. I have explained nearly 292 videos I have shown. If you wish, you can subscribe my channel and you can listen, and you can contact me. This mail ID you can take from Velingiri sir, and if you type my name in Google, you will find my phone number also, my email ID, everything is available in Google itself. You can type and make sure 29 members, at least 20 members, you can subscribe my channel. So this is in Thailand. I have presented in the year 2000. The 2012 I have presented. Then it is in Singapore. It is in Thailand. It is one of the keynote speaker at Geetham. Then this is Madanapalli Institute of Technology, resource person. This is in Sri Vidyaniketan Engineering College. This is jury member. Then it is a keynote speaker. It is my doctorate award from JNTU Anantapur. Then this is a Bharat Vidya Ratan award from Delhi. Then this is one of the best IT teacher in Andhra Pradesh. Then it is best IT best spoke for NPTL. I got award, felicitation award in that IIT Madras. Then this is international seminar we are conducted at Salem. This is at ICT-based pedagogy in engineering education. Then ISER Tirupati, I have given as resource person. This is at Sangam University. This is at ABS Ghaziabad, Uttar Pradesh. So one of the resource person. Then Jaya Engineering College, Tamil Nadu. This is Maharshi Markandeya. This is Blue Crest University, Liberia. This is Oman. Oman Big Data Analytics using Spark. This is at Liberia, Blue Crest University. This is at Russia, a School of Young Scientist COVID-19 strain virus detection. Then this is at Blue Crest Liberia. This is at Russia. And this is Blue Crest Liberia. This is at Bharati Dasan University. Okay, one of the resource person. Then Lord's Institute of Engineering and Technology. This is at Blue Crest, Liberia. Reva University. Karpaga Vinayaka College of Engineering. This is Vijnana Bharati. This is at Ghana. Then Krishna University, KL University, Chadalawada Ramanamma Engineering College. This is Annai College of Arts. This is Chalapati Engineering College, Annamacharya Institute of Technology and Sciences, Cyber Security, Liberia, Blue Crest Liberia, and Maharshi Markandeya University, Blue Crest Liberia on mobile application development using Python, VET Institute. This is at Reva University. This is at Oman. This is at VET Institute of Arts and Science, VET Institutes. This is Karmavir Advanced Babu Rao Ganpat Rao Thakre College of Engineering, Bombay. And this is SSN Engineering College, Maharshi Markandeya, and Bansal Engineering College, Ravindra Engineering College. This is Vikrant Engineering College. This is at Sri Sairam Engineering College, Chennai. This is Cyber Security at Blue Crest, Mahendra Engineering College. Okay, so then Bansal Engineering College. This is Research India Foundation. This is Research India Foundation, JNTU Kakinada. This is Model Institute of Engineering Technology. This is Rathinam Engineering College, Coimbatore. Srinidhi Engineering College. This is DCS MAT at Vagaman. It's Kerala. And it is MVJR Vishakhapattanam, Aditya College of Engineering. This is at Blue Crest University. This is Research India Foundation. This is at Dr. Abdul Kalam International Foundation. This is Research India Foundation, Panchanan Mohanty.
Sir,
Then,
sir,
yeah.
we have
So,
1 minute
yeah.
time.
Yeah.
1 minute away from this session end. Okay.
Yes,
So,
sir. Yes, sir. Any doubts, my dear friends? I am closing the session. Any doubts, please ask me. Please subscribe my channel, my dear friends. So far, only 5 members has done. Remaining members, any doubts, please ask me. My details are available with Professor Velingiri, sir. Okay. Please do subscribe my channel, my dear friends. Any doubt, ask me right now. Hello. Please ask me doubts, sir.
sir, I think no more queries.
Yeah.
Sir, hello,
Yeah,
sir.
yeah.
Yeah,
Yeah,
yeah.
yeah. Please ask me.
Sir, can you differentiate between sigmoid and sigmoid function and Rayleigh, leaky Rayleigh function, sir?
Yes, yes. Very good. See, if you are performing any